Welcome to the Decent Crypto Podcast. Today is Friday, November 4th, and we are live with our most requested episode by far, the deep dive on Solana. I'm here with Matthew Blumberg, who's coming to us live from Lisbon. I don't even know where you are, Matt. Where in the world is Matthew Blumberg?
I'm in Lisbon for Solana Breakpoint, actually.
Oh, let's go, baby.
This is why we're recording this episode now, because I didn't feel like reading the documentation, so I thought I'd wait until I could ask some Solana nerds what's going on.
It's a great call. I also forgot that you were there for Breakpoint. Every week, Matt's like, I'm in this city for this conference that I didn't go to, but it's great here, man. I'm like, all right, cool. So that was Where in the World is Matthew Blumberg, brought to you by the Decent Crypto Podcast. How's Breakpoint been so far? How are the Solana people?
As per usual, I didn't go to the conference.
Classic.
But it's cool. It's a really interesting alternate world. And, you know, I think there's a lot of promise behind Solana. It's not going anywhere anytime soon.
Hell yeah. Yeah, Matt hits me up.
To the end of the episodes now, folks.
Matt hits me up. He's like, yeah, man, can we delay a little bit? I'm reading Anatoly's Medium. It's like, okay, yeah, let's delay for a little bit. But here we are. We're ready. We are live. Matt, how ready are you? I think this is like 6 months in the making.
100%. Yeah, we've been meaning to do this on episode forever. But you know, let's jump right into it.
So let me start with this, as we always do, Matt. Why does this exist?
Solana exists to scale blockchains, right? They call it.
I thought it was to pump SBF's bags. That's what I hear. That's what everybody says.
That's what I mean by scale blockchains.
Oh, yeah, duh. Yeah.
Scale in that direction, yeah. So, you know, just to like put it in context, right? So Ethereum or Bitcoin currently, it's about 5 transactions per second, right? Ethereum are sitting around 10 transactions per second. You know, sometimes it goes a little higher, maybe 15. Solana is currently processing 2,800 transactions per second. That's over like the last 24 hours, right?
And those are actual stats. Those are not theoretical stats.
Yeah, that's an actual stat. The theoretical stat is 65,000 transactions per second.
Nice.
So it really is doing a lot of scaling, right? It's you know, sort of at the core of Solana is this idea that we can scale things like hardware and network throughput and optimize the software to run at high speed. And by doing that, we don't need to sacrifice composability. That's sort of the idea, is like scale bigger, scale horizontally, I guess, rather than vertically.
Okay.
But and you know, to give some idea for just how darn big this thing is, on average, Solana is expected to produce 4 petabytes of data per year.
Okay, petabytes. I just have no context for that. So terabyte is the largest that I actually think about. So what? How much bigger is it?
Gigabyte, about 1,000,000 gigabyte, or sorry, about 1,000 gigabytes. That's a terabyte, right?
A terabyte, yeah.
A petabyte is about 1,000 terabytes.
Okay.
So it's about 1,000,000 gigabytes. 4 petabytes per year. 4 million gigabytes. Think about that. That's an insane amount of data, especially when it's just like transactions on chain, right? Like this isn't like music or movies. This is pure transaction data. That's really, really, really big. So, you know, like I was talking to some people that operate like Solana validators last night. They're like, yeah, it's like 7 petabytes for the full historical like archive, which is just absolutely ginormous. Ethereum, I think, is around 2 terabytes. So
interesting. It sounds like already we're running into some trade-offs, right? Like about, you know, just things that I'm hearing. If I was listening to this for the first time, it's like that's just a lot of data that you would have to store if you're running a validator. I don't know how they felt about it, but you know, like maybe that's cause for some concern. But let's start from the beginning as to why this thing even why it exists, right? Like why it was created, who it was created by. So It was founded by two guys. The lead, kind of the kind of brain behind this, is this guy Anatoly. Are you gonna try and say his last name?
Yakovenko.
Yakovenko. Nice, dude.
Anatoly
Yakovenko. It's a great name.
Yeah.
So Anatoly, he wrote this white paper in 2017 about a new, is it a new consensus mechanism, or is it a new kind of, how do you describe proof of history?
Proof of history, I think, gets a little bit overblown. It basically is just kind of the same thing as blockchains, where you have an order of things, and the history part is like the order of the blocks, because each block references the previous block's hash. That's the way that you prove like the history of the blocks.
Got it. So
we'll get into where it's used a little bit.
The reason it's important is because this was a core part of the white paper that he released in 2017. He teams up with one of his colleagues. So Anatoly used to work at Qualcomm on distributed networks as a distributed networks engineer, right? So doing literally creating networks for fiber optic cables, things like that. Do you know specifically the kind of stuff that he was working on?
I'm not super sure, but what I know is that Qualcomm is very the way that we all know it is the Qualcomm Snapdragon chip, which powers a lot of Samsung phones, right? And he was doing a lot of stuff with, it was I believe it was telecom, distributed network communication.
Mm-hmm.
But Qualcomm in general, it's just a very low level company, right? Where you're engaging in packet level optimizations, kernel level optimizations. So it's it's pretty darn technical. It's deep in the weeds.
Yeah. So he brought on another Qualcomm engineer, I think, what's his name? Greg Fitzgerald. And they started building out Solana. So this blockchain, based on his white paper. Solana came out in beta in early 2020, so really not that long ago. I think I want to say January of 2020, something like that. And then mainnet was released March of 2020. So it's been 2.5 years that this thing has been in existence, and it feels like it's everywhere, right? It feels like everybody has Solana on their mind. It's living rent free in all of our heads, but it hasn't really existed for that long. For context, Ethereum, the white paper, yellow paper, I think first was released in late 2014. The mainnet was launched in the ICO was it in mid 2015 or early 2016, something like that?
It was mid 2015, yeah.
Right. And then so it's been 7 years, right, since this thing has been up and running. And then for context, Solana 2.5 years. It's relatively
so crazy. I mean, in this space, it's so easy to forget how young everything is, right? CryptoPunks are not that old. Apes are way younger, right? NBA Top Shots happened
interestingly, if you look at it that way, CryptoPunks are twice as old as Solana. They've been around since 2017 or 18, right? Something like that. So yeah, that's wild, right? CryptoPunks are twice as old as the Solana blockchain. It's just so weird to say out loud. But so that's just a little bit of history. The other founder of Solana is this guy Raj Gokal. He's on the more handles the business development ops side of things. Has a background in scaling startups, medical he was at a medical device startup, couple of medical device startups.
Interesting.
Pretty interesting kind of set of people. I think the one notable thing here is, and this is something that I think is going to apply across the space for years to come, is that these guys don't necessarily have crypto specific backgrounds or crypto specific, they weren't OG degens or anything like this. They come from very they have a lot of experience in like their space and like what they're doing, right? Like, you know, like scaling businesses or like doing kind of like you know, like building networks basically, but not specific to blockchain. And I think actually that's a reason why they've been able to be so successful, is they have this different lens.
Do you know how Anatoly got into crypto to begin with?
I've heard this story, I feel like on some podcast, but I forget it. What is the story?
It was like him and his buddy, and they were interested in doing like AI, like machine learning stuff, and so they had a whole bunch of GPUs, and then they were trying to figure out a way that they could use like use them to mine Ethereum, in order to subsidize the cost of doing the AI research on the machines that they wanted to use to do it.
That's
Uh,
wild.
yeah.
That's pretty interesting. Okay, so let's start there. Let's just pick up there, right? So these guys, you know, they write the white paper, they build the chain. What are the core components of what they're building, right? We mentioned proof of history. That's one thing that everybody talks about. You kind of mentioned this. The way it's described in many cases is like an internal clock, but yeah, it's just a set of a set of transactions that have happened over time, like in the history of the chain. What else is really core to proof of history?
So if you think about I think the clock is a really good comparison here. So if you think about Bitcoin, the way I've always thought about Bitcoin is that its core contribution to the world is having a decentralized agreement on the order of things happening, right? It is its own sort of clock, right? The idea being that if you try to submit a double spend to a you know, trusted single party, they're just going to choose as they want, you know, as they wish, like which transaction came in first, and then like nullify the other one. So when you have like a centralized system, it's really easy to have that notion of time, right? But when you have a decentralized system with no leader, right? Then it becomes more difficult to agree on like the order in which things happened. So the key innovation here is having this chain of blocks, right? Where you can, I mean, look, first there's proof of work on Bitcoin that, you know, is like, so, you know, Bitcoin has like, if you think about the secondhand ticking, each tick is one more block. But you also need a way of like verifying the order that the blocks came in. And that's where you know, the block hashes come in. So each block refers to the prior block's hash, right? Proof of history, sort of similar, right? So it's really, its main problem that it's trying to solve here is the exact same thing, which is like, how do we have some decentralized way of verifying the order of things? And so, you know, they have something called a verifiable delay function, which is like kind of a bigger, broader component of computer science, right? Which is, can you have some function that guarantees that something happened before something else, or that like a certain amount of time passed between two events, right? In this case, that a certain amount of time passed between block 1 and block 2, right? And for that, this is really easy. You just include the hash of block 1 in block 2, right? And you know, that proves to you that like it comes next, right?
Okay.
In theory, computing a hash is like really fast, right? And so it doesn't really guarantee that much time has passed, but it guarantees that some amount of time has passed between block 1 and block 2.
Okay.
So this becomes important because of the way that Solana like broadcasts transactions across the network. So it's a proof of stake system, right? And at any given, they call it a slot, but like at any point in time, you can think of a slot as like a block, right? They even use this word slot, I believe, in proof of stake Ethereum. There's one leader that is making that next block, right? The way it works is transactions come into the leader from all of the nodes that are like collecting transactions from users. So you sign a transaction, it goes to some RPC node, and then that gets directly forwarded to the leader, right?
Okay. And how is that leader chosen? Like who gets to be the leader? So if you and I are running a validator and staking, like we get to be the leader. Like how do we become the leader?
It's the same way that proof of stake works for Ethereum, where like a certain number of blocks ahead, the leaders are chosen, right?
Okay.
And the
It's
way it
just
works is
randomized, or
it's pseudo randomized. The way it works is it uses as a like for in a random in like a randomness like random number generator, you have something called a random seed. And you know, so on your computer, like if you have Python open and you go, okay, give me one random number, give me another random number, give me another random number, given the same random seed, numbers 1, 2, and 3 will always be the same, right? So it's a way of like starting the randomness. It's a seed, right? And the
okay.
randomness grows from there. They use a block hash as the random seed, right? So at block 100, maybe that's chosen as like a seeding block for blocks 101 through 200. And based on that, you can deterministically say block 154 will be like, you know, this leader, right? 155 will be that leader. 156 will be the next leader. So it's deterministic, but random, if that makes sense.
Yeah, okay.
This is important because this whole thing is happening like really quickly. And so it's useful to be able to optimize the communication flow. So you really only want to send the transactions to the leader that's gonna be making the appropriate block for it, or to the like next like 5 leaders or whatever, because there's a little bit of like, you know, randomness involved.
Yeah.
So if you sign a transaction and leader A is making a block, and then leader B is next, and leader C is after that, when you submit your transaction to the RPC node, it should really only send it to the next like 3, 4 leaders, because
Okay, I
it's
see.
likely to get into a block for one of them.
Yeah.
So you minimize, like you optimize the communication channels that way.
Okay.
And this all goes back to this Qualcomm background of these guys, right?
Yeah.
It's like just trying to optimize data flow.
Yeah. And so the whole point of that, like this whole thing that you laid out, is just to minimize speed, like latency, really. Like
Latency,
you don't want to have things going back and forth unnecessarily, like passing on these communications over like tons and tons of different channels when you don't actually need to, right?
Yeah, you don't need every node in the network to know about every transaction before it gets into a block.
And the trade-off there, right? Like the reason other networks do this, like the Bitcoin blockchain, right? Every transaction, it's not necessarily broadcast to every single node, right? But the kind of thing that you're solving for here is you want things to still be sufficiently decentralized, right? Where like you don't just want one node getting past every transaction and then being able to censor what goes through, or then having total control over the ordering of the transactions. That's the situation that you're trying to avoid, while still providing as much speed as possible and as little waste, little latency in the communications as possible.
Yeah, exactly. And so that's like just step 1 of the user submitting the transaction, and it goes to like the block producer, right? The leader. Then that leader needs to, so if you think about like in theory, right? If this leader ingests like, maybe they have a gigabit internet speed, right? And so they ingest a gigabit's worth of transactions. It's like 50,000 or something, I forget. They need to then tell everyone, hey, I saw these transactions. You know, they strip out the invalid ones, right? And then they need to like broadcast those to enough nodes in the network that everyone can sort of know what the block is going to be. So in Ethereum, the way this works is the leader assembles the block and then broadcasts that one block to like a couple of people or like a few people. And then Gossip Protocol takes over, and then all of the nodes can attest that like, yeah, I saw that block, right? In Solana, the throughput is a lot bigger, to the point where like actually like maybe sending the block to 2 parties is like not feasible. With a gigabit internet speed, you would need 2 gigabit output, right, in order to like send it to 2 people. And so instead, the way it works is the leader handles well, so first they filter for like just valid transactions. This is just checking signatures, right? And they check to make sure the signatures match, and then they, in a streaming fashion, they stream out these little chunks of blocks. They're called like entries or shreds, right?
Okay.
And so if I'm the leader, I might send one, you know, I'm collecting transactions constantly, and then I'm also streaming out bundles of transactions constantly. One to you, one to my friend, one to another person, and then you guys cross communicate, hey, here's the shred that I saw. Okay.
That makes sense.
But you need some way. Okay, so like say each shred is like 10 transactions and the block's gonna have like 1,000 transactions or something,
Mm-hmm.
right? So we have 10 transactions in, split out into 100 different shreds. I can I can now output one shred to each of 100 validators on the network, and then you guys can just cross communicate as needed. But you need some way of knowing, like, well, which shred happened first, right? And that's where proof of history comes in. So within a block, you're also hashing the shreds, and each
Interesting.
shred gets the hash of the prior shred, and that
Mm.
way you can assemble them correctly. Um, does that make sense?
So not only are you trying to optimize the communications or like the basically the yeah, just like the flow of information like between blocks, but you're also trying to optimize within a block.
Yeah, exactly.
Interesting. Okay, that's fascinating.
The idea
Um,
being that the leader should really be primarily responsible for validating transactions, for
mm,
validating those signatures, right? And then they just broadcast to like whoever can handle a little bit of that work, right? Or a
mm-hmm.
little bit of like that block. And then they're like, you guys worry about it. Tell everyone else about this.
Yeah.
And so broadly speaking, that's where proof of history comes in primarily for Solana. It's actually that part. It's not a consensus mechanism, right? It kind of is, but it's, not at the block level. It's like the intra block level. It's for these shreds of transactions. Um, so then the shreds sort of get reassembled into a block, and then after a certain number of shreds, the rest of the like validators in the network will submit vote transactions.
Okay.
These also go back to the leader. The leader tabulates the votes and broadcasts those through the same like output mechanism, and then that way everybody can come to consensus. If there's like, a super majority of nodes have voted that like this is the current state of the blockchain, then
Mm-hmm.
like at that point it gets passed over to the next leader.
I see. Okay. And so this is generally like how the block formation goes, right?
Yeah,
Like, is
that's
that
the block formation exactly.
okay?
And so you can kind of start to feel that like the whole thing is built a little bit for like maximum optimization,
Mm,
right? Like proof of history, for example, is a
mm-hmm.
really interesting one because similar to Bitcoin, you can perform all of the hashes in parallel, right? Like, so, block one or, block two has the hash from block one and the data from block two. You can
Okay.
hash that.
Yeah.
But at the same time, if you have the list of hashes then and the list of data, you can also say, okay, block three is going to have the hash of block two and the data from block three. And so, you can verify that all of the hashes are correct in parallel
Mm,
for all of the blocks at the same time.
mm.
Similarly, for the proof of history, right? For each like chunk of transactions, you have like some signature. And so the leader is like signing each of these things too, right? So you got to check that the signature is valid, that the prior block or the prior chunk hash is like the one that should be included, that the hash matches, right? But you can do all of that in parallel. And so it makes it really easy to check that, like, okay, I've got my 100 chunks of the block, and let's make sure I assembled it correctly. You can do it all in one go.
Mm. Okay.
Um, yeah, that's the other kind of core component of proof of history is it has that nice property of being like being verifiable like really quickly. Whereas
Okay.
like as you're building it, you have to first generate the hash from the first one, then you have to use that to generate the hash from the second one. So it takes a little time, and that's kind of where the time component comes in on the building. But on the like verification and like reassembly part, you can just like do it all in one go. Um,
Okay. That makes sense.
Proof of
Um,
history. What a concept.
yeah.
I think it's
Okay.
not really that big. You can see why I'm saying like it gets overblown because it's super similar to just like blockchains, right? To just like even Bitcoin blockchain has all of the same core features.
Yeah. I think the one thing that is, is maybe different and or maybe I'm just like not fully understanding is this like you can run everything in parallel or you can verify everything in parallel. Um,
Um,
is that different or is that or am I just understanding that wrong?
So with Bitcoin, right, like the primary thing that you're concerned about is the like input hashes to output, right? And so you have the input, you have the output, you have each of those for each of the blocks, right?
Yeah.
And you can check them all at the same time. You don't really have to check block 1 before you check block 2, before you check block 3. Like if they're all checking out correctly, you just run like however many blocks worth of hashes and just double check that the answers match.
So are you saying if you're on, like, let's say we're on block 30 or whatever, right? To verify the previous 29 blocks, you're saying that you don't have to verify each one like one by one? Or are you saying that as the blocks come, you don't have to verify them each like sequentially?
Yeah, I'm saying if you get 30 blocks worth of data, you don't have to verify them sequentially. You can verify them all at the same time using like multiprocessing, right? Just like parallel compute.
Okay, I see. But to get the hash for block 2, don't you need the hash for block 1?
It's more like if someone passed you all of the blocks and all of the hashes, then you could just double check.
I see.
Yeah.
I see. So just the verification process. That exactly. Can all be done at once. You don't have to wait for it to do it sequentially. Okay.
Yeah.
That
so
makes
it's fast.
Sense.
It's the same thing as a lot of things in crypto where it's, or, just cryptography in general, where it's really fast to verify, but slow to like crack.
Right. Okay. Yeah. Okay. So that is proof of history in a nutshell.
Yeah, and it's the block production like setup in Solana, broadly speaking, in a nutshell, right?
Yeah, go ahead.
Well, I was just gonna say, like, there's, if we're switching gears, there's one more thing that makes Solana really, really optimized, right? Which is this thing called the C-level runtime. So Solana is not EVM compatible.
Right, and that's Ethereum virtual machine. What is the virtual machines for Solana? Like, where is all this computation happening?
It's in something called the C-level runtime.
Okay.
So Solana, like all of the words are based on are basically based on like oceany stuff. So these guys worked for Qualcomm in San Diego, and Solana is actually named after Solana Beach, where they used to go surfing, which is like in like North County in San Diego. And
I really want to turn my laptop around and show the sticker that you got me. In fact, I'm just gonna do it. Let's see if I can catch the sticker. There's my burr. Where's the Solana Beach sticker? Oh, there's my Larry David. Oh, decent. Keep talking.
Oh, there we go. Solana Beach. And so C-level is like the runtime name, right?
Nice.
I get, as long as we're talking about terminology, you want to hear like a really cool thing. So in Bitcoin, like the smallest measure, or the small measure is the Satoshi, right? Or a SAT for short. In Ethereum, you have Wei, which is, I believe, a cryptographer, right? Named after some famous cryptographer. In Solana, you have Lamports. Now, this is named after, I want to say it was Leslie Lamport, who was a computer scientist and professor. And this is actually the person who built the LaTeX programming language. Or LaTeX, everyone's gonna yell at me. LATEX, and that's the like way that when you read a white paper and it's formatted in that nice like PDF style, where like you really can't get that with Microsoft Word, but like it looks so like sciencey and mathy.
Right.
That's LaTeX, right? And this guy built this thing because he was so frustrated with the state of the world for like technical publication on computers that he took a year off from his job as a computer scientist, went into a cabin in the woods, wrote this entire thing from scratch, and came back out a year later like, okay, what's next? That was the birth of LaTeX. Yeah.
Amazing.
Yeah. So Lamport is the tiny unit in Solana.
Nice. Amazing. I love that.
Okay, so moving on from terminology here. So the C-level runtime it's like Solana's version of the EVM. It's the virtual machine where like all the logic happens. It specifies like all the things that can happen on chain, right? And it has like one really crucially core feature that makes it very difficult to write code for, but very, very efficient. With Solana, whenever you call like a function in a smart contract, as part of the call, you have to tell the virtual machine, here is the list of addresses that I'm going to interact with during this call. So
okay,
let's say
so two things. First of all, why do they do that? And two, how does that make it more efficient?
okay, so they
I
do
guess
that
number two answers number one, but yeah.
Yeah, it is to make it more efficient, believe it or not. So the if I'm sending you USDC, right? What we would do is we would call the USDC transfer function, right? So as part of that, we would have your address, my address, and the USDC address, right? But if two of our other friends, friend A and friend B, are sending each other USDT, then they touch three completely different parts of the blockchain. And these two parts don't interact at all, right? So we can process them in parallel. And so this is another way that they speed up the throughput, right? So the leader is constantly getting a stream of transactions and needs to process that like the signatures and like inputs and outputs and all of that are like valid. They can, if they see two transactions that don't touch the same contract, in Solana you call them accounts instead of addresses, then you can compute those in parallel. Right?
I see. And so what about the transactions where the SOL token is involved, right?
Yeah, so the way that Solana accounts for tokens is like a little bit different from the way that Ethereum accounts for tokens. Okay. So on Ethereum, when you have USDC, it is its own contract, right? And USDC has a function called balance of, and it checks the balance of whatever address you call it with, right?
Okay. Yeah.
So on Solana, however, like it's an account-based system. So this is what makes Solana block scanners so difficult to read, right? You have your main account, right? Your user account, but your account owns several other accounts. And one of them would be your account's USDC account, right? And that account holds a balance of USDC. So the actual tokens themselves are built as part, the SPL token is built as sort of part of the protocol. And it allows you to send me USDC at the same time that two other people are sending each other USDC, as opposed to on Ethereum, that USDC contract would have to get passed in twice, right? So in reality, when I send you USDC, I'm actually just plugging in my USDC account and your USDC account as the input accounts that are going to get touched on chain.
Okay, that makes complete sense. And are there situations? Okay, so does this limit certain things at all? Like, are there any kind of trade-offs or drawbacks to this kind of thing? Because it seems like this is just a pure upgrade, where it's like, if you just have, because there are so many different contracts, right, that are deployed. There are so many different wallet addresses or accounts in this case. And you would imagine that they're all mostly not cross
interacting.
Yeah. And so this just seems like a pure upgrade, but are there any drawbacks or trade-offs that you're making in doing this?
It makes it way harder to code, right?
Oh, interesting.
So I would say
level?
First,
like on the application level, to build anything on top?
It was not easy to build this as part of the core Solana protocol. So that's like the first part, right? So Ethereum has had account abstraction on the like wish list for a while now, right? I want to say there's an EIP for it. I think it might have been proposed by Vitalik. So account abstraction is like nothing new, but when they were building Ethereum, like, and this is kind of something that I find really interesting, when you're writing a smart contract in Solidity, you know, people always talk about Solidity being like, being not ideal, right? Like having its drawbacks, right? And I didn't really understand, you can understand conceptually what that means, but then as you're writing Solidity, even as just like a total amateur, like just, writing out a simple program, you can actually feel the places where it's suboptimal. You can see the it's like when you go into a building and it's like not well maintained, and it's like, watch out, there's a loose wire, right? You're like, it's that same feeling here. Where you're like, wow, this was put together very hastily, right? Don't step on that floorboard over there. It might fall.
Yeah.
So, Ethereum is littered with things like this, right? Like, I stand by it. I think Solidity is just a fantastic programming language. It gets the bare minimum done, and it's always relatively clear what you're doing, and you don't have to be that technical to understand it.
Okay.
Right? It's the Python of smart contract development. And it also encourages best practices as a result of gas consumption, which I personally find pretty cool. Because when you're writing Solidity, like, there's always one right way of getting something done, because someone else has figured out what the most gas optimized way is to do something, or like the best trade-off of gas optimization relative to like code legibility. Right.
That makes sense. Yeah.
And so there's just a huge library of sample like code snippets, and that they're the best way of getting something done. So with Solidity, you don't have this like open, like blank sheet of paper the way you do with Python. And in Python, there's like 9 different ways of getting anything done, and they're all generally roughly as correct as one another. In Solidity, you don't have that. You have like generally 1 or 2 right answers, and that's really nice. It's a very special world of computing where like complexity is directly penalized through gas costs, right? There's a financial cost to making your code worse than it should be, which is spectacular. It guides you as a programmer. Anyway, for all of that, so look, like, for all of its flaws, I like Solidity a lot, but it does have flaws. And one of them is that, like, yeah, we never got this account abstraction directly into Ethereum. And instead, the way that tokens have to work is they have to like maintain this like list of addresses and how much like balance each of them has. And so some of it is just like, historically, it was harder to build this thing. And Solana is a lot younger. And so they had time to learn a little bit from the missteps of Ethereum devs, right? That's cool. The other thing is, though, and this is where it becomes, a little bit more bearish, is it's harder to write apps. It's just like way harder to write a Solana app than it is to write an Ethereum app.
Okay. And that's purely because of the language?
It's partially because of the language, which is Rust, right? And Rust is loved by people who love computers, right? I am not self-categorized this way. Rust is for people who learned C++ really well and thought, man, this sucks. I wish there was something better. And then they learned Rust, and they were like, finally, something safer than C++. Like, Rust is safer than C++. And if you're someone who knows what that means, then you love Rust, right?
I see.
But if you're you and me,
I was going to say, what is like safer in what way? Like
memory allocation. I think like there's little things like where if you write your code the wrong way, you can get exploited, because like the way that memory works in in whatever construct, like the computer sees it as one continuous like array of zeros and ones. And if you can somehow trick the program into like going over that array, then you can overwrite data from somewhere else and like hack. So you can imagine Spotify's app is like adjusting data from like Chrome directly in your memory. I'm sure there's like and then there's like a gazillion like safety measures in place to make sure it doesn't happen. But in theory, like, Rust is just like way safer. There's all sorts of other things too that I'm missing because I never actually learned Rust, but I tried.
Okay.
And so Rust is hard, right? But the tool chain is hard. That's the other thing. Like, when you go to write an Ethereum compatible app, there's a gazillion tools for you. There's Remix, where you can literally write it directly in your browser. And if you feel like deploying to like mainnet, you can just do it with MetaMask, right?
That's cool.
There's also like, you can spin up like virtual blockchains, like virtual Ethereums in your, on your computer, where you just have like 100 accounts and they each have so much ETH, and then you do whatever you want with them to like simulate and like test things, right? So when you're writing software, you can do it that way, or you can fork mainnet if you want to, using the same toolkit to like, to say like, okay, what would happen if I ran this on mainnet right now? And it all connects super nicely to infrastructure providers like Infura and Alchemy. Just like when people talk about like the developer ecosystem and the EVM tooling, that's what they mean. It's these little things that are like, man, this is so nice. I can just press play and simulate like how my contract will run. I have 8 testing libraries to choose from, and they're all fantastic, right? I can simulate running it on mainnet. I can run it on testnet. I can do it in my local blockchain for my, in my computer's database, just like with like one line of code getting changed. It's really, really easy to build Ethereum apps, right? Like just the infrastructure is fantastic. But for Solana, it's like they're still actively working on this stuff, right? For a while, none of this stuff even existed for Solana. So, you had to like, as a Solana developer, you actually had to care a little bit about like systems engineering and like, architectures and like basically spin up your own Solana blockchain. But like, that's way harder than spinning up like a dummy Ethereum blockchain.
Yeah. So in a way, it's actually super bullish to me that they've been able to get this massive ecosystem going, and that they have like, people building these kinds of things now, even though they don't exist as of yet. You can see people working on it, and like they've done all this in just a couple of years. So in that sense, it's pretty impressive. I can see where it's holding a lot of people back from coming in, but and I'm not a developer in any sense, but like from what I hear, Rust is actually like a good or a fun language. It's like a very modern language, modern programming language. Like a lot of people are learning it that are like learning computer science now. Is that the case? I mean, and if that is the case, I can see that being something that is is a positive down the line once they have these things built out. But I can totally see how that's holding them back so far.
Yeah, that's a really interesting point. It is bullish that they've managed to bring developers in, right? Given all of the difficulties and headaches surrounding it, right? Like you literally have to be like a DevOps specialist and a smart contract programmer and just like generally a Rust like engineer in order to like build anything on Solana.
Yeah.
And the fact that you can do that is pretty intensely cool, right? It reminds me a lot of like Starkware, right? Like I was talking to a bunch of people building on Starkware a couple days ago at the Starknet CC conference. And it's a good energy there because it's people that are like, yeah, I don't care how hard it is to build in Cairo. I'm just going to do it because it's the tool that supports like the app that I want to build. They're people that are like ready to walk through walls to get built what they want to get built. Right. So to me, that's super cool, right? Like this is where the innovation happens. This is where the people who are actually passionate about this stuff live. Right. And it's definitely a similar vibe on Solana. It just makes it harder. It makes it harder for a lot of things. Like for example, to get a smart contract like audited on Solana, the wait list is like 3 times as long as it is for Ethereum at any given point in time.
Okay.
Right?
Yeah, that makes sense.
Moreover, like you can fuck up more easily, right? Like the stuff's not as battle tested. Everyone's still learning. So look at Wormhole, right? Like the Wormhole like attack happened because there was a vulnerability, and it would have been caught with better tooling, but it wasn't. And then by the time they found it, it turned out the exploiter already knew about it. And so I don't know if you followed like I think we talked a little bit about this.
We did, yeah.
Like the order of events was these guys find the bug. They submit the code, like the pull request that should fix the bug to GitHub, right? And then the attacker sees that they're going to fix it and immediately exploits. Like they were waiting for more assets to be amassed in Wormhole. And, once it became clear that they were going to fix it, they had to execute. But it was,
wild.
It was like an issue with like an underlying library, right? And it's just like this kind of little thing is like so much harder to deal with in Rust, right? Like I can deploy a Solidity app and feel fairly comfortable that I built it correctly as like a not super technical guy, right? I could never do that in Solana. It would take me years to reach that level of comfort, and maybe I never would, and I would just deploy something that like maybe it could have an exploit, right? But it's very much the Solana approach, right? Like the move fast, break things thing, right? Like, should we talk a bit about the downtime?
Yes. So, well, is there anything else that is a core component of the technical stack that builds Solana? Like if we're just walking through how the blocks are made, how they're confirmed, is there anything else in that whole process that we haven't really hit on? Right.
I guess we should talk about fees.
So yeah, so I think that was the one remaining point on my side. That'll also lead into the token. So that kind of wraps it in terms of like tech, like core components, like how it's differentiated from Ethereum and other EVM chains, and the things that just generally build it up, and like why it's reached so much I don't know, like widespread appeal. It does solve for a lot of things that Ethereum simply can't right now, and really no other chain is built to as of yet.
Yeah, the intent behind Solana was to create a blockchain that could support a full central limit order book, right?
So I have a question about
the
this.
NASDAQ of blockchains, right?
Was that the like central, like core goal for them from the very beginning?
Yeah. I mean, this is generally what Anatoly has said, right? Is like, I wanted to build this to create the, like the global central limit order book, a global real-time price discovery mechanism, the NASDAQ of blockchains, right? And you can see it in a lot of these decision choices to like, for example, like when you pass in which accounts are going to be touched before you go into like a contract call. If you and I are trading like ETH/USDC and someone else is trading like Wrap Bitcoin Sol, no sweat, like they can match each other, right? And so like they can match each other at the same time, the same way that that a central limit order book servers within like NASDAQ or a centralized exchange would work too, right? Those two markets don't interact. Similarly here, like that was the idea. But it leads to some design decisions, right? So like the fee markets are probably, or lack of fee markets, that's probably a good thing to hit on now.
So yes, so the final piece is this. Like, all right, let's walk through. Let's just start from the beginning yet again, right? Transaction happens. You, Bob, are sending me, Alice, some Solana tokens, right? You sign from your wallet. Now, what exactly happens from there, right? Like both from your side and from the block producer side, right? The block producer side, we walk through a little bit, right? It needs three inputs: your address, my address, the contract address, right? And depending on those variables, like the transaction can be processed like by a certain entity and in a certain like order, right? From your wallet in my wallet, what exactly is happening? Is it just the normal kind of thing? You just sign a transaction, it gets broadcast to the nearest node, and then the block production process starts.
Yeah, so it's a little bit different from the way Ethereum works, where like they don't really have much. They don't have like a real mempool in the same way that they have on Ethereum. So, just zooming in a little bit. So I sign my transaction. It goes to my RPC provider, right? Or like any node on the network that I can connect to, right? My nearest node, as you were saying. That node looks at it, and this is kind of interesting. When I sign a transaction in Ethereum, I sign it with a nonce, right? And so that's like an incrementing counter of how many transactions my address has signed so far. And that way, like which one to process when you see two conflicting transactions with the same, at the same time from me. You know that transaction number 5 needs to go before transaction number 6, right? And if you ever see another one with transaction number 6, you know that like that's a replay and like it's not valid anymore, right? This prevents like replay attacks basically. On Solana, the way this works is actually you reference the latest block hash that you've seen.
Okay, interesting.
Yeah, and blocks are like every 1 to 2 seconds.
Yeah,
right?
yeah.
So your wallet software is in sync with the blockchain, tracking what the latest state of the blockchain is.
Okay, got it.
And
it's going to use that data to sign another transaction.
Well, that's useful because it gives you a bit of a baseline for like when that transaction got submitted, right? And based on that, you can say, okay, the last block this person saw was block 100, right? I only need to really tell, and then each block has like an assigned block producer, an assigned leader, right? Based on proof of stake, right? So last block I saw was block 100. Please put it in one of the next blocks. And then the RPC node says, okay, one of the next blocks, that's probably like, I don't know, like 5 blocks. And so you know who the leaders are going to be for the next 5 blocks, for blocks 100 through 105. And you just send the transaction there. You don't actually broadcast at that point in time the transaction to everyone the way that you do in a mempool, right? You only broadcast it to the people that you're expecting to need it, right? Because they're going to turn around and broadcast it to everyone else through this like, split and then reassemble mechanism with proof of history involved, right? So eventually everyone will find out about it, but they don't need to find out about it until it's included in a block, right?
Okay, I see.
And so this simplifies it, like separates the concerns, right? Where like instead of like cross communicating every single incoming transaction, you just say, all right, who are the like 5 to 10 people that actually need to know about this? I'll just tell them.
Okay.
Right?
And that process, what does that do for, again, like the censorship aspect of it, the permissionless nature of it, right? So it's like if the block, or like if your transactions are only being broadcast to like a very select few, block producers, the next few that could be the leader to produce that block, like does that provide any kind of opening for people to be able to more easily censor transactions in some kind of way?
Yeah, I guess a little bit, right? But the thing is, assuming people aren't censoring, then those are the only people that really need to know about it anyway, right? Assuming that they are censoring, you just submit your transaction a second time, because part of the point of having the block hash instead of the nonce is that like after a certain number of blocks past that have been produced, you can be guaranteed it'll not be included on chain again. So it keeps getting passed around until it is included on chain, right? But if you hit that like timeout number of blocks, then you know that like, okay, that thing's not coming in, I can sign it again, and then the next like 60 validators or whatever, right?
Okay, got
will
it.
be able to see it,
right?
Yeah, it's a little clunkier, but it's not much worse for censorship resistance, right?
Yeah.
Because these are the only people that are going to make blocks anyway.
Yeah.
Right? Like, doesn't do you much good if someone that isn't going to make a block for 2 years, or whatever, sees your transaction or
okay.
not.
Yeah. My main question is like, if it doesn't get in one of those blocks, right, in the next few, then is it like just never going to happen? Because that's something that's happened in Solana where it's just like a lot of transactions are just stuck because they can't process, because, again, like there's no fee market. So it's like, so then, let's walk through the next step, right? Like, okay, your transaction then is broadcast to the people that could be potential block producers for the next few blocks. Let's say one of those block producers, like what happens? They just take it, like they accept the block or they accept the transaction. Then they put it into a shred, or like what exactly happens?
Yeah, a shred. Yeah, which is like a batch of transactions from inside the block.
Yeah.
And then they tell someone about that shred. And then they have their next shred, they tell someone else about that shred. They have the next one, they tell someone else about that one.
Okay. Then that shred gets passed to...
They all cross-communicate.
Okay. And so what happens to each shred then? Like they're all being told to who? Is it within that same group, those like 5 to 10 block producers that could be in the next block? Or is it just that one block producer who's the leader of the block is being passed a bunch of different shreds from different validators?
So the leader is just getting a stream of transactions like one by one, right? They're bundling them into... The way that it would work on Ethereum is they'd bundle them into one block, and then tell the entire network about the block. But that's actually a little bit slow, right? Because it has this bottleneck of that one party being the one that communicates, and then from there it all has to propagate. What they could do instead is intake like transactions one by one, bundle them into smaller chunks of the block, and then tell a few people each about that chunk, right? And then the next chunk, and then the transactions are still coming in, they're still validating all of the signatures, and then they're still chunking, and then they release the next chunk, right? And then the rest of the like nodes in the network, or the rest of the validators in the network, they're each getting some number of chunks, coming in and out like during that time. And eventually they'll have seen all of the chunks in that block, and then they can rearrange the chunks because they know what order they're supposed to be in, because they have this like signed like proof of history chain thing that gives you that order of chunks.
Okay, got it. So it's only the leader that is sharing these shreds, or like creating these shreds, basically, right?
Yeah, the leader creates shreds, right?
I see.
And they're like partial blocks, basically,
yes,
right? Like
okay,
it's instead of like
sense.
waiting until the end to share the whole block, they can be like, all right, I'll share a little bit with you, I'll share a little bit with you.
Okay,
and then you guys figure it out amongst yourselves, and you can reconstruct it, and we'll give you like more than enough data. And they have like a little bit of redundancy baked into to make sure that like if one validator is offline or whatever, it doesn't mess with it.
Okay, so that makes sense. So then the leader takes all these shreds, they make a block. Or like as the shreds are coming in, they start propagating them across the network to everybody. Like, hey, I got these batches of transactions. They're all valid. Let's, boom, we're all good to go. Hey, it's all gravy. Now that leader, let's break that down a little bit more, right? So like these shreds come in. How is the leader making shreds? Like, how does he decide this one is going, these transactions get batched together into this shred? Like, let's say, you said right now we're doing 2,800 transactions a second or something like that. Let's say the chain is getting overloaded. There are hundreds of thousands of transactions happening every second, or trying to happen every second. How does, the network decide which transactions go in which order? Like, how does the network decide that?
So, so the way that like the scaling would work in that case, right, is like you want to think about like what's the bottleneck, right? So generally speaking, it would just be like first in, first out, right? Like I get first 100 transactions, put them in a shred, tell people about them, get the next 100, put them in a shred, tell people about it. And then the whole network knows that like there's going to be a certain number of shreds per block. And once that gets hit, everybody says, great, I've got this number of shreds. Me too. And then you start voting on like, okay, after this 100 shreds, like this should be the state of the chain. And then everybody else submits their votes. You hit a super majority that gets broadcast back to the leader. Leader broadcasts everyone's votes as like one last shred. And then everybody updates their state of the chain to reflect the result of the vote. Right. So think about what happens when like more transactions are coming in one by one into like this guy's like CPU like memory, right? Into the leader's computer, right? They can do something called like parallel signature verification, right? Where, because what are they really doing when they're a validator, right? Like they're not necessarily updating their state of the chain so much as they're checking the signatures.
They're verifying, they're verifying signatures, right?
Yeah, and in the vast majority of Solana transactions, the single biggest like use of resources is actually checking those signatures, right? Like the single biggest use of CPU, right? And so you can do that in parallel, right? Because each transaction you're just checking like the associated signatures, right? And so that's like one way that they speed it up, right? And then when everybody goes to like update their state of the chain, there's another speed up, which is that, okay, I can update state in parallel for transactions as long as they're not touching any of the same accounts, right? And you know which accounts they're going to touch because they have to be passed in.
Got it. Yep. Okay, that makes sense.
So the way it scales up is like, so the issue really around scalability, like overwhelming stuff, right? If we go back to this idea of Solana as like NASDAQ of blockchains, right? That assumes that like most of what's going to happen here actually is just like trading of digital assets, right?
Yeah.
But you might have more complex logic. You might have logic with if statements and like for loops and like really weird stuff, right? Like you might have a lot of like logical paths that a program can take as it gets executed. That can be like more expensive computationally and take longer to update the state of the chain to reflect what happened when more stuff happened, when more complicated stuff happened. So that's one issue, right? Generally not a huge issue today, given that like most of the compute that's happening is like not that complex, right? It's like mint me an NFT, swap this token for that token. It's not, it's not a huge issue today, right? And there is like a limit on the total amount of compute that you can put into one of these things. So generally, we're kind of safe there.
Okay.
The bigger issue is when people want to touch the same contract. That's really what leads to downtime. And so like it's worth touching on the fee market here, I think.
Yes. Let's talk about the biggest topic in Solana, transaction fees. So Matt, let's start with this. What are transaction fees used for in Ethereum, and how does that differ in Solana?
So in Ethereum, transaction fees are used to prioritize. They're used for two things, right? They're used for like directly making it costly to have complicated logic executing on your smart contract.
Okay.
This is why like NFT trading is more expensive in gas than like ERC20 trading or just sending ETH. The more logic that's happening, the more stuff each member of the network needs to like do in their local CPU in order to like update their state of the chain to reflect
And
it.
so really quick, why is trading an NFT like an ERC 721 token? Why is that more computationally expensive than trading an ERC20 token?
Okay, maybe that was a poor example.
Okay,
basically,
I know I see what you mean though. Just anything that requires more computation will require more cost, will be more expensive.
Yeah.
Okay.
Yeah, exactly.
Yeah, that makes sense.
Generally, with the 721, the reason it winds up being more expensive is because like the exchange contract that you're using, whether that's like OpenSea, like Wyvern or Seaport, or like I think Coinbase uses 0x, right? That contract has to check a bunch of things, right? So when you put your NFT up for offer, you sign that message and it has to like go in and check the signature, and that's computationally more expensive than just like updating the number of tokens that each like party has in a swap.
Okay, I see.
There you're just updating two numbers and computing the price and then updating two numbers accordingly. On the NFTs, you have to check signatures and stuff, and then update the numbers accordingly.
Yeah.
So it's more complicated.
Okay, that makes sense.
So the more complex the logic, the more you have to pay in gas fees, right? The cheapest thing you can do on Ethereum is just send ETH, right? That's got the cheapest, like you can think of it as like a complexity penalty, right? It's got the least amount of like compute consumed because it's baked into the protocol to be like the cheapest thing to do. It is like a native function to that protocol.
Yeah, and like if you're thinking about it computationally, right? Like just like logic wise, right? You're doing one function, you're like calling one function, right? It'll probably be a very simple line of code that says like, I don't know, send. It's probably just that. And then the input that you're taking is like the other person's wallet address. And so for a computer to take that and then to execute that, to like read the chain, to like pull the assets from your address and then to send, it's not much logic, right? It's a couple of steps. And so that's not going to cost you very much. But then to do something like if you're doing leveraged yield farming, to take two different assets, send them to a pool, combine them in a way, and then take leverage out on them. Borrow some assets, put them into the pool, hold that open, and then also close out the position if this happens. All of that has to be then put into one transaction. That's going to take many different steps, a lot of logic, a lot of computational resources, which will cost you a lot more. So that's one way that transaction fees are implemented in Ethereum. What's the other way?
The other thing is like primarily for congestion.
Okay.
Right. So when a lot of people want to access, want to update the state of this machine, right? You can create a market. The Ethereum's approach has been, let's create a market for that, right? And whoever wants to get their transaction through first can pay a little bit more, right? And so you have your like total gas, which is like the compute consumed, right? And then you also have your gas price, right? And you multiply those to determine how much ETH you have to pay in order to get that transaction through.
Okay.
So, and then you have, other things, right? Like that you can tip the validator, right? So there's a base fee, which is like this, like, pure just like cost of consumption. And then there's also the additional fee, which gets paid out, the priority fee, right? Which gets paid out to the validator. Base fee gets burned, priority fee goes to the validator. Since EIP 1559 at least, right? On Solana, they sort of made this conscious decision that like, well, and this is really interesting. The priority here actually was uptime. They want to have a chain with a lot of uptime. And the logic is for people who can't, yeah, it's really interesting, right? So,
it's ironic.
Yeah, it is. So you can make the case that like at times of high congestion on Ethereum, that chain isn't really up for most people.
It's unusable, yeah.
Right?
Yeah.
It's unusable, yeah.
I mean,
and it might as well be down.
Yeah, exactly. I was trying to mint the Lazy Lions. I remember this. I was trying to mint the Lazy Lions, and the gas, it would have cost like 3 ETH in gas.
No way.
And this is when ETH was like $3,000. I was like, whoa, what's going on here? So yeah, prohibitively expensive. So what is Solana's solution here? Like, how do they solve for this?
So Solana's solution, right, is to have like flat pricing for each transaction, right? And the pricing is based on the number of, this is so interesting, signatures that have to be validated, right? And generally that's like 1, right? It's like your signature on this thing. But you could have on Solana, like the execution model is a little bit broader or like more generalized than it is on Ethereum. So you can have contracts calling other contracts. You can have a user calling a contract that like in turn stores a signature and can like later use that to like call another contract. There's a lot of like different like transaction submission mechanisms. And so you can have like for example, if I buy your NFT, that's got to process my signature and your signature. So that's 2 signature checks, right? And that would cost twice as much as just like me sending you some SOL, or whatever token, right? And so there's a little bit of that. It scales with complexity, but really the complexity that they're looking for here is not like the amount of data getting stored on chain or the amount of like computational stuff that has to happen to update the state of the blockchain. The way it is on ETH, right? Like one of the most costly things you can do on ETH, probably the most costly relative to like value, is storing data on chain. Storing data on chain is expensive on ETH. And a lot of the optimizations around things like ERC 721A, which lets you mint multiple NFTs at the same time, that just comes down to like having a more efficient way of storing the like ownership of whatever NFT in like an underlying like more compressed format with just like zeros and ones, rather than having like a dictionary of like token 1 goes to this person, token 2 blah blah. Anyway, storing data on chain on ETH is enormously expensive. And they used to actually pay you a little bit of gas when you destroyed a contract to delete the data from the chain.
Oh wow!
Because it shrinks the size of the
overall chain.
Oh
wow!
Yep. So this was like a really interesting thing you could do for a while, is when gas fees are low, create contracts that have a lot of data stored in them, and then you can like, I think they pay you like 70% of the total gas back if you call self-destruct on that contract.
That's so funny.
Yeah, really interesting. They don't do that anymore, and you can see this on chain. Basically, the self-destruct opcode is just like not used anymore. But this was a very common thing for people to do MEV, right? Where like at a time when gas was really cheap, you could rack up some gwei and like wait, and then you would be a more competitive player in the competitive MEV market than the next guy, because your gas came at a cheaper price.
So what are the implications of this for Solana? This like, this like complete change in how really like transactions are ordered, right? Like kind of like how they're prioritized in a way, right? Like how they're, it's a complete design decision. There is talk that there could be a fee market introduced at some point in Solana. But you know, what for now? What are the implications that you've seen as a, like, both as a user, as somebody who looks at the ecosystem, like as like obviously there's all this kind of uptime, you know, downtime, really, just a ton of downtime that we've seen. Like, just broadly speaking, is this model something that can work long term, or do they have to change it?
So the key thing here is really around the fact that you can only process transactions in parallel if they don't touch the same, you know, like Anatoly compares it to a light switch, right? You have a light switch, you want to flip it up and down, but you know, you have 100 people that want to flip that light switch, right? That's going to be a shit show, right? It doesn't even matter if the flipping of the switch takes a nanosecond versus like 2 seconds or whatever. It's still going to be like hard to like organize those people and get the transactions ordered, right? Effectively, what you're getting is somewhere between random to like first come, first served. Generally first come, first served, right? But like in practice, what that means is you want to randomly, like, you don't know where in the world the current leader is, and so you want to just like spam the network with transactions in order to hope that like you get to, you know, the one RPC endpoint that's like directly next to the current leader. Mm-hmm. And so look, you know, there is one thing, right, which is that you always know how much a transaction is going to cost on Solana, like deterministically, which is interesting, right? It allows you to create like contracts that can call other contracts, and like the, you know, the gas doesn't become like an issue. But you can also, you know, you can also wind up, and so like, for example, to send Sol costs 5,000 lamp ports. Okay. 0.000005 Sol. Okay. This is 1.5% of a basis point of a dollar.
Oh, okay? Baby.
So this is insanely cheap, right?
Yes.
And that's like pretty much set, right? I mean, the price of Sol changes, but yeah. The issue is that like when an NFT drop happens, and really like part of the issue here is that Solana was built for like to be the NASDAQ of, you know, blockchains, mm-hmm. right? Where like we'd just be trading like fungible assets. When an NFT mint happens and there's no allow list, everybody wants to touch the same part of the ledger, and there's no like real clear way of like knowing exactly how that should be getting processed, mm-hmm. right?
Yep.
And so there is now a mechanism called a priority fee where you can add a little bit on top if you want to get your transaction in more quickly. It's not to the point where it's like a functional market the way that it is on Ethereum. And I don't think Phantom will let you like automatically adjust your gas or whatever, you know, your tip to support it.
Yeah.
But that's coming soon, right? You know, according to like, it's like partially implemented if you go to the GitHub right now.
Okay. Interesting. It's so funny. The more things change, the more they stay the same. I think it's good that, you know, they're acknowledging the fact that these are real requirements from real users and they are adopting. Is there anything else on the technical side, on the fundamental level, that you want to get into? There is an infinite array of things that we haven't even touched on, especially around what people are building, around some of the actual events that have happened, around what kind of use cases are unlocked with the stuff that we've talked about here. Because this is more like, you know, primitives and like base level stuff that we're talking about, how the protocol is built. But, you know, there's a whole world, like you said, it's a whole separate world that's really being developed and designed and people are excited about, that if you're not really deep in the space, you won't hear about a lot of this stuff. Even something like the basic lingo, like shreds and things like that, you know, like I'm sure a lot of people have never heard of it. So there's a ton that we will continue to explore. There will definitely be a part 2, but on the fundamental level, is there anything else you want to get into?
Decentralization, just quickly.
Okay.
So common like thoughts around this is generally that like Solana is a VC chain
Mm,
built for VCs by VCs, not a chain that like your average person can really operate a validator for, or a block producer for, right? And that to a degree is true. So, crunching the numbers,
mm-hmm.
I got a quote yesterday, that like around the like cheapest you can get if you're just like putting bare metal in a data center, it costs you about $1,000 a month to operate a computer that can like be a validator on the Solana blockchain,
Okay.
right? The other thing is that validators have to vote like pretty often on what they think the current state of the chain is.
Mm.
So you got to add about 1.1 SOL per day,
Oh
right?
wow. So that's like
So
$30, $40. Um,
yeah, and so the rule of thumb that they've been that they told me, which if you crunch the numbers, it's about right, is that at 6-ish% return, you really want to have roughly 500,000, maybe a little bit less, staked in order to make it worth it to operate that
okay,
validator.
got it. Because it'll cost you
Um,
maybe 30 grand a year.
about 30 grand a
Yeah.
year.
Okay.
Yep. And there's like little other costs too. So they
Mm-hmm.
recommend 500K.
Okay. And how many validators
So
are up right now?
okay, so this is pretty interesting.
Mm-hmm.
Guess.
Well, I have the number, so it's gonna be hard.
Oh, so you already know it. Okay, yeah. There's a lot of
There's
validators
a
up right now.
ton.
There's over
Yeah.
1,600 active
There's a
validators
ton
right
of
now on
validators.
Solana.
1,600.
Come the fuck on. How many how many validators do you think there are for Polygon?
One.
100.
Oh.
Yeah.
100.
How many?
Okay.
I mean, we don't know how many there are for Avalanche, right? But for any Tendermint based chain,
It's a
it's like less than
max 100, right?
100.
Yeah.
And look, like in reality, this is 1,669, right? Like there probably
Yeah.
are
It's
multiple
probably,
operated by like the same
yeah.
parties, right? Like just that's knowledge like centralizes, right? But if you're gonna think about it that way, how many validators are there for Bitcoin,
Yeah,
right?
exactly.
Like
There's like 5 mining
mining
pools.
pools,
There's
right?
like
Yeah.
5 ETH staking pools. Like it's, it all comes down to the same thing. I think the cool thing about Solana is like, you can put in like, you can run the whole chain yourself, right? Like you can store the whole chain, you can run the whole chain yourself. Like you don't need to have a pool if you don't want to. It'll cost you 30 grand a year, but like, it's kind of cool. You can like run the hard, you can rent some space in in a server farm or wherever and like run the hardware and yeah, like it's kind of cool in a sense. And
It's permissionless,
yeah.
right? And it does kind of work, right? Like, and especially because you're rotating validators so often, you do get a pretty decent chance of getting roughly. There's not a lot of luck involved, right? You will get roughly that return, right? And so yeah, it'll cost you a little bit, but like you can do it as an individual, right?
Yeah.
With Bitcoin, you really have to participate in a pool because the blocks are slower and there isn't as much like
The financial
rotation of validators.
The financial reward is very low.
Yeah, so you can make a strong case that this is more decentralized than a lot of other networks.
Yeah, I think the sufficiently decentralized conversation is super interesting, right? Like it's everybody has kind of come to this, whatever, I don't know if it's a come to God moment, even the Bitcoiners, but it's like decentralization is very clearly a spectrum. And it's like, where does the sufficiently decentralized line lie? And I think it's subjective for everybody, right? Like, I think for a lot of people have made the case that 10,000, if you have 10,000 independent validators, that's like sufficiently decentralized for basically any system, which to me, that's a ton. That's just a super high number, but like 1,600 is a lot. Like getting 1,600 people to consensus or whatever it is, half of that, even a third of that, that's a ton. So
at this level of throughput, it's insane, right?
Yeah, it's quite
but
impressive.
I would challenge. I don't think it's so much a spectrum as like, what are you getting out of it, right? Decentralization is for a reason, right? Is it censorship resistance? Is it capacity to participate permissionlessly?
I think it's really just, yeah. I mean, I would say those two are almost the same thing, but like, yeah, censorship resistance is the end for decentralization, for sufficient decentralization.
Yeah. Yeah, it's a great question. But if you can operate a validator, then it's like, okay, well, maybe my block only comes every 100 minutes or whatever, but I can still get one through. Right.
Yeah. Well, that's a good place to leave it. Sufficient decentralization. Matt, thank you for this brilliant episode, this deep dive of the Solana network. We will be back in a few days with a recap of everything that happened this week and part 2 of Solana at some point down the line. Have a good weekend, everybody. Till then, stay decent.
None of this was financial advice, legal advice, investment advice, or any other kind of advice. If you're looking for advice, you are definitely in the wrong place. Until next time, stay decent.